Well, let me start by congratulating the team who has put together this colloquium because I was attending it virtually here from Oxford yesterday as well as today, and I've learned a lot, and that's what one hopes to get out of an event like this. So thank you as well to Liz Law for the very kind invitation. So, as it's been mentioned just now, my name is Rob. I'm based in Oxford. I've been an associate professor in ecology here for 2 years, and I am a population ecologist and a demographer by training. My dream is to be able to archive the demographic information of, yes, not just mammals and birds, as you can see in this depiction of Noah's Ark, but truly across the tree of life. And I see great potential in order to be able to use this information for teaching and learning. The take-home message of what I want to show with you guys today is that ecology is finally coming to the point where we can all play with each other's data, and the interoperability that emerges from these synergies really provides us with the unparalleled and unprecedented power to address questions that we simply couldn't before. A couple of years ago, my wife and I went to Japan. And we were stricken by this image that I'm taking the liberty of sharing with you. In it, you can see some individuals in groups, not necessarily talking to each other, but looking at their phones. I'm going to leave it with you guys to think about what exactly is going on in that photo. I'm going to come back to that later. One of my ecological heroes, E.O. Wilson, has very famously said that we're losing species at a much greater rate than we get to know them, we get to understand them, we get to protect them. As a consequence of this, there's been the emergence of very many open access databases that try to archive and make information subsequently available for the taxonomy, the conservation status, the genes, etc., etc. However, up until recently, there's been a gap in terms of the demographic knowledge of species. And this is important because it is precisely the rates of survival, development, and reproduction that make the Amur leopard be extremely endangered, whereas the high success through high investments in survival, development, and reproduction, again, make the cheatgrass species, Bromus tectorum, be a really aggressive invader in the US. So understanding the demographic rates of natural populations really position us in a right place to be able to carry out management conservation in a successful way, among other applications. Luckily, population ecologists are not new to this topic. And so we have been going out to the fields and we've been tracking information about lions and dandelions. We've been tracking information about orchids. We've been tracking information, oops, that just jumped over. We've been tracking information about a lot of different species. And unfortunately, up until recently, that information remained in a siloed. Most of the demographic information that we had obtained pertain to mammals and to birds and to some other tetrapods. And it's been one of the main missions in my academic career to try to archive information in other taxonomic corners of the universe. Luckily, matrix population models have come to the rescue. So in a matrix population model or stage structure population model, folks go out to the field. In this case, you can see a photo of me during my PhD, collect data on rates of survival, growth, and reproduction, archive it, and build a summary statistic from which we can then go on and obtain information about population growth rates, responses to disturbances, and many other really useful biologically meaningful metrics of population performance. As a consequence of how popular these matrix population models have become in the last decades, they've really exploited in the peer-reviewed literature. Here you can see two graphs that show the cumulative number of plant studies on the top and animal studies on the bottom, showing matrix population models. This is the contribution that in my group, the Salgo team at Oxford, we've been making to this gap that E.O. Wilson has identified. We have made two databases called Compadre for plants and Comadre for animals that archive hundreds and hundreds of NPMs or matrix population models. And with the help of one of my PhD students, Sam Levin, we're doing the same thing for other kinds of matrix models called integral projection models. And that database will become available very soon. So stay tuned for that. Compadre and Comadre became fully open access quite a few years ago now. Time flies, doesn't it? With the respective publications that you can see there. The ways in which the information in Compadre work is you guys go out to the field, or me, myself as well, of course. We do the field work, the analysis, and the publication. We've got set up a series of online automatic searches with keywords. This information then is curated, complemented, and once the embargoes that authors might wish to impose on those data have elapsed and agreed upon, they make their way out to the real world. This is our website. Let me show you for a second. So this is the main portal of Compadre. Hopefully you can see the numbers going up. So you can see that for plants, we currently have got 762 species with over close to 900 matrix population models around the globe, and 415 animal species with over 2,200. This is a world map that represents for each point the demographic information that we have archived. So as you perhaps might have suspected, the GDP of the country is a really good predictor about the information that we have for the natural populations in that country. You can see, for instance, that we've got quite a few data points here in Europe. Here's Norway. Norway could do a bit better, so I'm very keen on collaborations there, by the way. But just so that you have an idea, for instance, this point here corresponds to a Bristol population of the common fox, Vulpes vulpes. You've got here in Norway, you've got other populations of plant species. The important thing about these databases is that they're truly open access. So you can go to download Comadre, for instance, in the case of animals, scroll down, download, agree, and open that R data object in R. If you just type in Comadre $maths, you can obtain what's pretty much the equivalent to a overdose of demographic information. There's a lot of more information in Compadre and Comadre that I won't have the time to discuss with you today, but I encourage you guys to take a look at it. Importantly, we do have a lot of resources available. We've got a user guide in an effort to be able to be as transparent as possible and to help the users who use it. We have got also a link to an R package that we have developed that whose main utility is to be able to maneuver and to manage the information in Compadre and in Comadre in as fast and as an efficient way as possible. We also have got information and a Shiny Pop app actually developed by a colleague of mine called InStots, where you can use this for teaching purposes as we are discussing today. So here you have your drug of choice. You can choose plants or you can choose animals. There's a lot of different species here that you can choose from. So I'm going to choose this one, the desert tortoise. And then there's various matrices available to this desert tortoise. And we can see some basic information about the taxonomy, the ecoregion, where it's coming from, and other information about when it was collected and under what conditions. This is your matrix population model that contains rates of stasis, development, and reproduction. And we can also obtain some really useful information about life history traits, estimates of population performance, and questions related to perturbation analysis. What will happen to the population if we perturb it, perhaps through a drought, for instance, in different ways? So this is a tool that we've been developing within the Compadre and Comadre team and that we see has great value for teaching. We also have got a GitHub page. And this GitHub page has become a little bit of the heart of this enterprise. I'm not going to spend the time walking through all of the different materials here, but I do want to attract your attention to this folder called Workshop. We have given workshops in over 50 countries in 3 different languages, English, Spanish, and German. And some of these materials have made them into R Markdown and PDFs with a really clear and concise guideline that helps users from undergraduate all the way to researchers to use demographic models to address some really interesting questions in ecology, evolution, and conservation biology. So we've used these databases for a number of research documentations and research investigations, but we do really see a great potential to use this data to address teaching and engagement with some of the curriculum that we've discussed before. As I mentioned before, we've run over 50 workshops in 3 different languages, and Compadre and Comadre are now officially part of the curriculum, not just here in Oxford, where we teach population modeling and population ecology at the intro and at advanced levels, but also in other universities, including University of Hawaii, Connecticut, Stanford, and Southern Denmark University. If you're interested in using this resource at your own institution, please do get back in contact with me. Ultimately, the dream would be to go back to Japan and to take advantage of that potential that it is technology. We would love to be able to interact with users, students, and normal citizens alike, to be able to offer as much information as possible about the biodiversity that surrounds us all. So the dream is to be able to connect all of these resources in a way that connects with the citizens, with the students, and with the research community. Thank you very much.